we go. And we are recording. Okay, well, so welcome back. Obviously, we're not doing the same thing that we did last time. Last time I tried to use YouTube. That didn't work out too well. But hey, we're starting on time, so awesome. So today we're going to continue talking about we're going to continue talking about memory, and that's where we were at last time. So I'm going to bring up the whiteboard and I'm going to write down a definition or two. Here we go. Okay. So let me grab my. All right. So if you'll recall once again, you have in our model, there are 4 major components. And those are, of course, you have input. Oh boy, that's the class number. Input. Boop. You have, watch me struggle with this. You have processing. Gosh darn it. So that's obviously going to be too big, but whatever. Processing. We have our outputs. Output. And then finally, we have storage. Okay, I'm going to have to mute whoever that is. Because that is very distracting. Hold on a sec. Who is the noisemaker? Mute. Okay. Let's not do that again. All right. So going back to the whiteboard. Okay. So once again, you have input, processing, output, and storage. Boop. Okay. So we started talking about storage, but I didn't actually give you a definition. So when it comes to storage, when it comes to memory, we have a few definitions we can work from. Anybody care to suggest a definition for memory? Anybody care to suggest a definition? A place to store our data so that we can use it later. Yeah, it's a bit of a circular definition, but it's a decent definition. Just trying to see here, how many people do we have? Any other ideas? Well, I like to think of memory as a device. Oops. A device that can retain information over time. There we go. Just gonna stretch this out a bit. Yeah. A device that can retain information over time. Okay, can I move that somehow so that it's okay? gonna grab that. Come on. Oh, there's a select tool. I can grab the select tool. There we go. Okay, so yeah, memory is a device that can retain information over time. Now, if you recall the definition of information, information is an answer to a yes or no question, right? Information, as we defined it earlier in the semester, is an answer to a yes or no question. And so information was differentiated from data. So data is, once again, a quantity, some sort of quantity. So information is an answer to yes or no question. And memory, then, is the ability to recall information. So it's a device that can retain information over time. It's a device that can hold on to information over time. And this is a problem that we have worked with since really the beginning of time. So today I'm just going to kind of give you a bit of a history lesson. We're going to talk a little bit about the history of memory leading up all the way from the, Paleolithic all the way up to today. So I'm going to switch out of whiteboard mode. And we are going to then, oops, I've got somebody full screened here. Sorry, I'm just trying to unfull screen. Riley, I've got you full screened, and I don't know how to get you unfull screened. Way to go. Let's see here. Well, that's problematic. It's okay, Riley. It's not your fault. Let's see here. Manage participants. Ugh, I don't know how to get that up full screen, but whatever. Just try. There we go. Got it. Okay. So let's do this. All right. So any idea what this is? Any idea at all what this thing is? Just trying to show the participants. No idea what this might be? Just give me a guess. Is it some kind of scale? Is it some kind of scale? What do you mean by a scale? RAM? Technically no. RAM is a good guess. It's not RAM. It's actually other form of memory if you think about it. It looks like a bone. Well, that's because it is a bone, actually. So this right here, what you're looking at, is a Paleolithic wolf bone. So it's an ancient wolf bone. This is a tally stick. So it was a tally stick that was used in order to keep track of things about 30,000 years ago. So it's actually a counting device. So back in the day, say that you were in a agrarian society where you had to keep track of, say, sheep, right? Because one problem with sheep is that they like to wander off. And if you need to keep track of your flock, one way to do that is to, as each sheep runs past you, when you're recollecting your flock, to put a notch in either a stick or, in this instance, a bone, in order to count how many sheep that has returned. Now there would usually be like two of these tally sticks, right? You'd have one that would have notches that you would have used when you brought your sheep in, and then one that you would have used when you brought your sheep out. And if the number of lines matched up when you put them side by side, then you would be able to determine that you have all of your sheep accounted for, or all of your livestock accounted for. So this is an early way of remembering things. So what kind of memory would this be? What kind of memory do we have here? ROM, exactly. It's read-only memory, right? It's for long-term storage. So when it comes to counting, can you think of a so this is a non-volatile, right? This is a non-volatile form of memory. In fact, we are able to keep that information preserved for 30,000 years. I mean, that's a long time to hold on to memory. But can you think of what a volatile version of this would be? What might be a piece of volatile memory that a person may have used, say, to count their sheep? Counting in their head? Yeah, that's that. I mean, that's very volatile. How about something that doesn't rely on your brain? Lines in the dirt. There's another one. I'm thinking of a specific one that's basically always readily available to every single one of us at all times. Almost every single one of us. Exactly, counting on your fingers. Yeah. So you got random access memory right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is where we actually get, of course, our base 10 number system from. It's our ability to count on our fingers. And of course, it's volatile memory because the moment that you like start doing anything else with your hands, you wind up losing that information. You can actually count in binary on your fingers. Anybody know how to do it? So I can show you. So it's like this. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20, and keep going and going and going. So you can actually count in binary on your fingers, which is kind of cool if you think about it. Anyhow, so the volatile analog, I would argue, of this counting stick would be counting on your fingers. Now let's move forward a little bit in history, if we can. All right. So these are kind of cool. These are about 7,500 BC, more or less, is what we're looking at here. So these little clay counters, and so these are tokens from 3100 BC, and these originated in Iran. And they're used to keep track of various goods, right? So they're used to keep track of various goods. So, for example, you might have like how many textiles you purchased, and how much oil, livestock, etc. So this is basically a way that people, when they purchase stuff, when they were owed something, how they were able to keep track of what they were owed. And so what you do is you would take these little stone counters, and they would be baked into a clay sphere. So you can see there's the clay sphere. Why do you think that they would want to bake these counters? So let's say that I gave you, that I owed you, like, I don't know, 5 kilograms of textiles, a sheep, and some chickens. Why do you think I would insist on baking it into this clay sphere so that, say, a year later you could come back and reclaim it? Why would I insist on baking it into a clay sphere? Any ideas? Less volatile? It's a good guess. Yeah, I mean they are protected from the elements and whatnot, but I mean these are hardened clay tablets. The chances of them actually um, being like destroyed is pretty low. Any other ideas? Well, I'll tell you. Okay, so this was actually in order to prevent fraud. So one thing that you could do, because these are pretty simple to make, right? These are pretty simple tablets to make. So what they would do is, let's say that I paid you for, a whole bunch of goods, and you said, okay, in 6 months, come back and I will deliver the goods to you. Um, in order to make sure that I didn't go out and bake myself a whole bunch of these little coins, these little tokens, and make you owe me things that you don't actually owe me, I would insist on baking it into a ball. And so they bake it into this ball, and when they got back together after like 6 months or whatever, they would take that ball, break it open, and then inside it would tell you exactly how much you owed. So this is kind of smart. So this was to prevent fraud, and we are kept in this clay ball that would be smashed open upon redemption. This actually reminds me of something that so little counters actually reminds me of something that when I was growing up I used a lot. Anybody recognize these? Yes, it's Pikachu. I'm talking about the counters. So one thing that you could do, or one thing that you'd have to do when you were trying to keep track of, yep, they're damage counters. Exactly. So for example, poor Pikachu here, he's got 20 damage on him right now. And then I think this is probably like for paralysis or something. And so this helps you keep track. Mewtwo is poisoned, apparently. Um, this helps you keep track of exactly what status the cards have, how much damage they've taken. And so these are damage counters. Yeah, I think everybody's lost their damage counters. The wonderful thing about that, though, is that you can just go to like the dollar store. I don't know if you know this. You can go to the dollar store and go into like the craft aisle, and then you can easily buy a whole bunch of them. I still have loads of Pokemon cards. There's probably some within arm's length of me. There are some within arm's length of me right now. But yeah, these tokens, these are tokens that store values on them. And when you put the values on top of the Pokemon cards, that means that Mewtwo, for example, has taken 50 damage. Pikachu has taken 20 damage. And so, of course, once this reaches 60, Mewtwo faints. Okay, so these are counters. Now, of course, there are loads of different types of temporary measures of keeping track of how many of something there are. So, anybody know what this is? Yes, exactly. That is an abacus. So an abacus is an ancient counting device that you could use to really quickly tally up things. I actually have one. I'm just not sure where it is at the moment. I used to have one. I think I got lost in the move. But anyhow, yeah, this is an abacus. And so it helps you keep track of things. You can do little math with them. How about this one? Any idea what this is? It's a rosary. Yeah, so this is a Catholic rosary. And what does a rosary keep track of? Any idea what a rosary counts? Yeah, exactly. How many prayers you've done. Yeah, specifically like how many Hail Marys you've done. Um, and so the rosary, and there's lots of different religions have prayer beads like this, and this helps you keep track while you're in prayer. It helps you keep track of exactly how many prayers you said. Um, so we don't usually think about it like that, but that was interesting. Now, of course, this is CS207, and so we're talking about usually digital computers, digital electronic computers. So when it comes to digital electronic computers, I have said there are generally two different pools of memory. Okay, so there are generally two different pools of memory, and they have different uses depending upon which one you're talking about. So, any ideas what those two different pools are? RAM and ROM. Okay, yeah. So, RAM, one is for storing variables. That would be RAM. Storing variables. And you also have ROM. Now, what is ROM for? What exactly do we use ROM for? Because we use RAM to store variables. That's an actual question. I'm waiting for an answer. Anyone feel free to store the program. Exactly. So ROM is for storing programs. Generally speaking, storing programs. Now, I've talked a little bit about this idea called the von Neumann architecture. Now, the von Neumann architecture is a way of managing storage. The von Neumann architecture has built-in storage, meaning that the program is actually stored inside the computer. So that's what your Arduino and most of your computers have, is that it's called a stored program architecture. So it's stored right within the computer itself. Now this hasn't always been the case, and there's a lot of examples of different storage devices that are not contingent upon the computer. They're not the program is not stored inside of the computer. So, for example, let's go back to. Okay, so for example, anybody know what this is? any idea what this is? Hazard a guess for me? Bueller. Bueller. A punched card. Yeah. So this is a punched card. Exactly. It's a punched card. And this is actually a punched card for a Fortran program. So the punched card was actually stored external to the computer. And so the entire program would be punched into these cards. You can see here, this is a punch card writer and a punch card reader. So right here, you can see this is on the right-hand side of your screen there. That is the tool that you would use in order to punch cards. And on the left, there's a woman who is feeding a punched card into the computer. But the computer itself didn't have the program built into it, right? And this was actually kind of the norm back in the day. It was mostly this sort of thing. Here's another example. Here, this is ticker tape. This is paper tape. So this is a program that is stored on a piece of tape as opposed to being stored inside the computer. And so that's one thing that von Neumann did that was pretty original, right? He decided that it would make sense to store programs internally as opposed to externally. So it's really cool. It's a really cool idea. I like the idea of storing programs externally myself. I think it's a cool idea. Anyhow, so moving forward to purely electronic storage. So this thing right here, you see, this is called a drum storage device. Okay. Now, a drum storage device is a lot like a modern disk-based hard drive. So it's a lot like a modern disk-based hard drive that you're used to. So here's another example of a drum. And so the way that a drum-based storage, and this was primarily for ROM, so read-only memory, drum-based storage used a ferromagnetic recording material on top of a spinning platter. And this is exactly how your hard drive works today. So I'll just draw you a little diagram here. There's got to be a quicker way to switch between whiteboard and... Okay. So this is how a drum-based or a hard disk type system works. So you have here your disk, okay? And the disk is usually situated on some sort of a spindle, right? Now, this disk has lots of little magnetic particles that are on the surface, right? So there's all these little magnetic particles that are all over the surface. Now, these little particles, depending upon their orientation, they can stand for either a 1 or they can stand for a 0, depending upon which way they are facing. Now, what you do when you are reading one of these discs, or if you're writing to it, you have basically a little magnetized, it's a magnetized head is what they call it. And so what this little guy does is, because it has a magnet in it, it will flip these guys to be either in the 1 state or the 0 state. Now, of course, the disk spins around and it reads them as it spins, and it also writes them as it spins. Now, this is, once again, a form of read-only memory, or read-slowly memory, or I should say write-slowly memory, as opposed to random access memory. And that's because in order to actually read this thing and write to this thing, you can't just jump to any position, right? You have to read the grooves. It's like playing a record, right? It's like playing a record. You can't really just, you can jump to a position, but it won't necessarily be the position that you want it to be in. You have to read through the whole stream. Okay. And so this is how a hard disk works. Any questions about that so far? Okay. Just type in the chat if you have a question, and I'll try to answer it as soon as I can. All right. So going back, so this drum-based storage, right? This was a bunch of platters and a bunch of reading and writing heads. And so these things would spin and you would be able to read and write to us. This is a form of ROM. Now the early RAM, and this is really cool, the early RAM actually operated much differently. Okay, so this, what you're looking at here, this is called a magnetic core memory unit. Okay, so magnetic core. And the reason why we call it magnetic core is if you look really close, you'll see that there's a whole bunch of, these are called toroids. So a toroid is like a donut shape, right? And so there's all these little toroids. Now these toroids are made out of special material. I can't remember exactly right off the top of my head what sort of material these toroids were made out of. They were made out of they were made out of a hard magnetic material, usually a semi-hard ferrite. Okay, so they were semi-hard ferrite. Now, the cores here, depending upon, how should I put this? Depending upon the direction, so you can see each of these have a wire that's running into the center of them, right? So depending upon the direction that you send a current, it would flip the magnetic field of these little toroids. It would flip them so that they would be in either a clockwise or a counterclockwise position. So there's magnetic fields that are being generated around these. And when you send an electrical current through these wires, it will flip them to either clockwise or counterclockwise. So each core stores a bit in the form of a magnetic field that's either moving clockwise or counterclockwise. So this is really cool. This is really quite cool, although it's not exactly the most stable type of memory. Okay. And of course, the reason why is that it's really easy to disrupt these magnetic fields. And so you have to be careful around these. Now, actually kind of cool. You can still get like cards, mostly like from hobbyists, but you can still get little cards for your computer that you plug in, right? And that will still use magnetic core memory. And so it's kind of cool, although it's more of a geeky thing. I still haven't had anyone build an Arduino with magnetic core memory or build an Arduino project that uses magnetic core memory. That would be really cool. I would appreciate that. Anywho. Okay, questions so far? All right. Oops. Did that wake you up? I apologize for that. Okay. So yeah, then moving forwards, this we're talking about like the 1940s, 1950s. Okay. Whoa, you know. Whoops. I just jumped through. All right. Here we go. So in the 1970s, 1980s, somewhere around there, we started using, these are your standard hard disk, right? So these are the standard hard disk that you would find. I have a few laying around here. So like, here's one. This is a standard hard disk. If you open it up, you would see that there's a platter inside of it. I think I might have one that's opened up around here somewhere. Actually, one sec. Let me duck over here. For some reason, I have a collection of hard disks that are just laying around. I think it might be this one. Oh, nope, it's not opened up. But here's an older one. This is an old hard disk. This is what they look like. I mean, I'm sure you've seen these before. And then, of course, here's just a stack of smaller ones. Okay. So this is essentially what we're looking at here. Now, anybody know what this is called? A CD. Well, you'd be correct about the one in the lower left-hand side. That is a CD-ROM. But this big one here is obviously not a CD. Try to put that. A laser disc, yes. Yes, Blake. This is a laser disc, right? So laser discs were quite popular in the 1980s. And this is how we would store movies. Back in the 1980s, we would store movies on these big old laser discs. It's just like a CD, but it used a different type of laser, and it was much, much bigger. Then, of course, you probably recognize these guys. What are these? Floppy disks. Yeah, exactly. I have some of them sitting around here too as well. I have some sitting around here. I'm just not quite sure where I put them. Yeah, so these are floppy disks. Now, these are the original floppy disks, the ones that you see here. And they're called floppy disks because they literally, you could flop them, right? Now, what we call floppy disks today, what usually people think about when they say the word floppy disk is not actually a floppy disk. It is a floppy diskette. And a floppy diskette is about this big, 6.5 inch. And if you try to make them go floppy, they will break. So you don't want to do that. But that's floppy diskette is the little one. You can see there's a little floppy diskette right down here next to this big old reader here. And so these use kind of the same principle as your hard disk, right? They kind of use the same principle. It's more common with, I would say, a cassette tape. So a cassette tape probably has more in common with a floppy disk than it does with a hard drive, except for instead of being in a ribbon shape, they were in a circular shape, like an actual hard disk. Okay. Now, of course, speaking of, here's a bunch of, this is essentially take a floppy disk and chop it up into ribbons. Okay, so this is a, what do I call it? Just trying to think of the proper term for one of these guys. One second. Oh, magnetic tape. That's it. So this is magnetic tape, and this was first invented. This first used for data storage in the 1950s, and so the tape device was called a uniservo, and it was the main I/O device on the UNIVAC 1 computer, and the effective transfer rate was about 7,200 characters per second, so relatively fast actually. And the tapes were metal, and they were about 1,200 feet long, so that's pretty cool. Now, this next one you have seen already. What's this? It's not a cassette tape. You're close, but no cigar. Somebody else want to try? If it's not a cassette tape, it is a what? It stores data. I'll give you 5, 4, 3, 2, 1. Okay, this is a data set tape. This is a Commodore data set tape. And so essentially this was the, we talked about this when we talked about computer, when we talked about data over audio, remember? Yeah, remember? We talked about this when we talked about data over audio, data set tapes. Okay. And just because we had talked about this before, I had told you about the cathode ray tubes in the back of the ENIAC machine, and this is the actual back of the ENIAC machine with the cathode ray tubes. Anywho, so just to recap, today we went through and we just covered some of the history of storage, and so we've been storing things in weird ways for a very long time. I didn't get nearly into depth as I usually do. On Wednesday, I'll try to move on to talking specifically about the Arduino, and I'll teach you some little tricks that you might be able to use with the Arduino in order to take advantage of all of its memory. I'll stick around for a couple of minutes or a few seconds here. We have to be out of the room in 2 minutes because the next class has to come in. But if you have any questions, please do let me know. Otherwise, let's go back to. If you have any questions, please do let me know either in the chat or in Discord. Otherwise, thank you very much for your attention, and I will see you on Wednesday. Oh, I just remembered the next class is my class. So we can take as long as we want. The March 20th lectures are already on YouTube. I'm going to post this one on YouTube as well. Oh, hey, Peyton.
Hello.
Finally, somebody talks.
I'm here.
Yay.
It's a person.
I will be right back.
Oh, bye.
Let's see here. Going to pause.
It's Emily. Yay.
I'll be right back.
Aw.
I'm not going to be writing anything down on paper right now.
Oh, hi, Matt. I can hear you.
What's up behind you?
Thank you.
Whoops.
Hello.
Hello.